Okay, step 3. Eliminate a different variable and solve. Step 4, find a second value. So substitute the value of the variable found in step 3 into either of the equations in two variables. Last step, step 5. Find the third value. Use the values from steps 3 and 4 to find the third value by substituting into one of the original equations. Okay, I'll give you guys a second to finish copying this, or if you'd rather just take a photo of it really quick with your phone or something, that way you can copy it down later. Either way is fine. Okay, let's look at an example. Example 1. Okay, here's our system of equations. We have 4x plus 8y plus z equals 2. That's our first equation in our system. Second equation is x plus 7y minus 3z equals negative 14. Third equation is 2x minus 3y plus 2z equals 3. Here's our system of equations, 3 equations. Okay, so our first step says we need to eliminate a variable. So we can choose X, Y, or Z. It doesn't matter which one. I usually try to look at the coefficients of each variable and see which is going to be easiest to work with. But in a system that has 3 variables, usually it's not going to matter. You're going to have to do some work no matter what variable you choose. So let's just choose to get rid of X. Okay, so if I wanted to get rid of X, I could use the first and second equations. I would just need to multiply the second equation by -4. Since we have a positive 4x here, if we multiply this equation by -4, that would give us a -4x, and then the x's would cancel. Okay, so we're going to multiply the second equation by -4. When we do that, we get -4x. I'm going to go ahead and write it below this first one. We get -4x minus 28y plus 12z equals -4 times -14 is a positive 56. So we multiplied the second equation by -4 and wrote it here below the first equation. Okay, so let's combine these equations. When we combine them, the x's cancel, which is what we wanted. 8 plus -28, it's the same as 8 minus 28 is -20y. Z plus 12z is 13z. And 2 plus 56 is 58. Okay, that was step 1. Step 2, eliminate the same variable from any other 2 equations. So we need to eliminate x again, but we can't use the same 2 equations. We have to choose 2 different ones or a different combination of 2. So I could use the first and the third or the second and the third. If we chose the second and the third, we would just have to multiply the second equation by -2 to cancel out with this positive 2x. Okay, so let's do that. Multiply the second equation by -2 to get -2x minus 14y plus 6z equals positive 28. So we multiplied the second equation by -2 and wrote it here below the third equation. Okay, so combine these 2 equations, the x's cancel. -3 plus -14 is -17y. 2 plus 6 is 8z. And 3 plus 28 is 31. Okay, now we have 2 equations that just have y and z. So we're basically starting from here, the way that we worked all the problems on the worksheet from last time. We're going to eliminate either y or z by elimination. Okay, so we're not dealing with nice and easy coefficients. We've got 20, 13, -17, and 8. Those aren't the easiest to work with, but we can still do it. So I would choose to eliminate the z because the coefficients are smaller. 13 and 8 are smaller than 20 and 17. Because what's going to happen is we have to multiply this equation by 8 and this equation by 13. And we also need those to be opposite signs. So one needs to be negative and one needs to be positive. So we'll multiply this equation by negative 8, not 7. And we'll multiply this equation by positive 13. Okay. Negative 8 times negative 20 is positive 160. Negative 8 times positive 13 is negative 104. And negative 8 times 58 is negative 464. Okay, the second equation, 13 times negative 17 is negative 221. 13 times 8 is positive 104. And 13 times 31 is 403. So again, not the nicest, easiest numbers. They're fairly big for what we're used to in solving systems of equations. But that doesn't mean that there's anything wrong. Now when we combine these equations, 160 plus negative 221, that's the same as 160 minus 221, we get negative 61. Negative 104 plus 104 cancels, which is what we wanted to happen. So if that didn't happen, we did something wrong. And negative 464 plus 403 is negative 61. Now we have an equation that only has one variable. So we should be able to solve and get a value for that variable. All we have to do is divide both sides by negative 61 to get y by itself. Negative 61 divided by negative 61 is positive 1. Seems like a lot of work to just get y equals 1. But that's what we have to do. Okay, we're not finished yet. That got us through step 3 in the steps that we wrote. Now step 4 says find a second value. Substitute the value of the variable found in step 3 into either of the equations that have two variables. Okay, so these are our two equations, one right here and one right here that just have y and z. So we're going to plug in this y value into either one of those equations. It doesn't matter which one. Okay, I'll just choose the second one. Negative 17y, but we know y is 1, plus 8z equals 31. Okay, now we just have an equation that just has z. So let's find a value for z. Negative 17 times 1 is negative 17. add 17 to both sides. We get 8z equals 31 plus 17 is 48. Divide both sides by 8 to get z by itself. We get z equals 6. Now we have two values, and our fifth step is to find the third value. We use these two values that we already have. We go back to the three original equations and we choose one to plug these values into. Again, it doesn't matter which one. I'll just randomly choose the middle equation, x plus 7y minus 3z equals negative 14. So we've got x plus 7y, but we know y is 1, minus 3z, but we know z is 6, equals negative 14. So that's x plus 7 minus 18 equals negative 14. Seven minus 18 is negative 11. Add 11 to both sides. We get x equals negative 3. So now we've got all three of our variable values. The way that we write this solution, normally we would write an ordered pair because we just had x and y. Now we write an ordered triple, x, y, and z. So our solution to this is negative 3, 1, 6. Any questions? You'll have to unmute or put in the chat. I know it's a lot. Finding the very first value is the most work. Once you find the first value, all you're doing is plugging in and finding the other two values. Okay, let's do example 2. Our three equations are x plus y plus z equals 2, x minus y plus 2z equals 2, and negative x plus 2y minus z equals 1. Okay, just looking at the coefficients of this system, it seems like this problem is going to be a lot simpler to work, not too crazy of numbers like we had in the first example. So we started last example by eliminating the x variable. Let's choose a different variable to do this time. Let's choose y. I see, first of all, the first two equations, one's positive y and one's negative y. Those two will cancel out without having to do anything. So all we need to do is write these two equations on top of each other so that we can combine them. x plus y. Actually, I'm just going to move 1. I'm just going to move this second equation and write it down here. X minus y plus 2z equals 2. Didn't have to multiply by anything. All I did was move it so that now we can combine these first two equations. X plus x is 2x. Y plus negative y cancels out, which we knew would happen. And z plus 2z is 3z. Then we have 2 plus 2 to get 4. Okay, now we have an equation that just has x and z. So we need another equation that just has x and z. So we choose 2 different equations out of the original 3 to eliminate the y again. Okay, I see if we multiply the second equation by 2, that would give us a negative 2y. That would then cancel with this positive 2y in the third equation. So let's do that. So we're multiplying the second equation by 2. And we're going to write it below the third equation because that's what we want to combine it with. So 2 times x is 2x. 2 times negative y is negative 2y. 2 times 2z is 4z. And 2 times 2 is 4. Okay, let's combine these two equations. Negative x plus 2x is just x. Positive 2y plus negative 2y cancel out. Negative z plus 4z is a plus 3z. And 1 plus 4 is 5. Okay, so now we have two equations that just have x and z. And the coefficients on our variables are a lot simpler than what we had in the first example. So the first thing I noticed is that our z terms both already have a coefficient of 3. It's just that they're both positive. So if we made one of them negative, those would cancel out. It doesn't matter which one we do. Let's just say we use the first equation. We multiply the first equation by negative 1, and we're going to write it over here below this equation. Negative 1 times 2x is negative 2x minus 3z equals negative 4. Combine these two equations. X plus negative 2x is negative x. 3z plus negative 3z cancels out. And 5 plus negative 4 is positive 1. Okay, all that's left to do is make this x be positive. So we'll divide both sides by negative 1 to get a positive x equals negative 1. Okay, we use this value for x. We go back to either one of our equations that just have x and z. Doesn't matter which one. And we plug this value in for x. I want to use this equation, x plus 3z equals 5. So instead of x, we're plugging in negative 1 plus 3z equals 5. Add 1 to both sides to get 3z equals 6. Divide both sides by 3, we get z equals 2. Okay, we've got 2 out of our 3 values. Now we just have to go back to one of the 3 original equations and plug in x and plug in z to find y. I'm just going to use the first equation, x plus y plus z equals 2. X is -1 plus y plus z, which is 2, equals 2. -1 plus 2 is 1. So we have y plus 1 equals 2. Okay, sorry. We are subtracting 1 from both sides to get y equals 1. So we write our solution as an ordered triple, x, y, z. So x is -1, y is +1, and z is 2. Does anybody have questions about these 2 examples?